Assalamu alaikum. Hello, everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's session, we are going to solve May-June 2020 paper. This is of S1, Probability and Stats 1. And this is the second variant, which is 52. We are all aware of the instructions. Now, first of all, I need some space to list down the time at which I'm starting. So it's almost 12:05 p.m. and I'm starting at this time. And then at the end of each question, I'll be noting down the time. So exactly 12:05, let's get started. The first question, find the value of the variable x. For n values of the variable x, it is given that sigma x minus 50 is 144. Let me start underlining. Sigma x minus 50 is 144. Sigma x is 944. Find the value of n. Now, first of all, you need to realize that this is a question related with coding. And when something like this is given, something is subtracted. So this is about coding. So let me introduce a new variable. Let y equals to x minus 50. Therefore, sigma y is 144 and sigma x is 944. And how are these two related? These two can be related like this. Y bar is equals to x bar minus 50. Now, y bar can be found by dividing sigma y by n. X bar can be found by sigma x over n. So let me write down the values. So sigma y is 144 divided by n. That is x bar, which is 944 over n minus 50. So let's take 50 to the other side. 50 equals to 944 over n minus 144 over n. So 944 minus 144, that is 800 over n is 50. And n comes out to be 800 divided by 50. The zeros cancels out. And therefore, n comes out to be 16. So I did this whole question without even using the calculator. So that was so simple, but conceptual. Yes, you have to make sure that you understand the relationship between y bar and x bar. Whatever is the relationship of the original variable, that is also the relationship between y bar and x bar. So it's 12:07 over here. And let me write a little bit exaggerated time. So let me write 12:08 p.m. So that is end of question number 1. So we are writing the ending for each question. So now this thing is done. Let's move to the next one. So this question, what is it about? What do you think it is about? It is about probability, and then some conceptual stuff. So let's get started with this question. It's still 12:07. So now we are starting with this. A total of 500 students were asked which one of 4 colleges they attended and whether they preferred soccer or hockey. So there are 2 kinds of sports. So we have soccer, we have hockey. The total is there. And then there are 4 colleges, college A, and then college C, and then college B, just for the color, I skipped it, and then college D, and then college E. So no, that's not college E, that's the total. So there are 4 colleges and 2 types of sports. Now, what we do is that it says find the probability a randomly chosen student is at Canton College. The student is at Canton College and prefers hockey. So this is Canton, this is hockey. We are not looking at the total for Canton. A student is picked from the total. How many are they? 500. So this is Canton, this is hockey, this is 56. So let me write over here, direct answer, that is 56 over 500. And let me also write over here, no rounding off is necessary because the examiner did not say so. All good, all clear? So the first part is all done and dusted. Now let's move to the next one. It says find the probability. Let me again underline. I pay a lot of emphasis on underlining. Find the probability that the randomly chosen student is at Devar College given Now the word given is there. That is related with conditional probability. Given that he prefers soccer. So now, first of all, focus on soccer. So soccer is all together, that's 280. So that means 280 is the denominator. And students are from four colleges: College A, College B, College C, and College D. But we are interested in these people, which is College C, actually College D, that is 120. So let's write 120 at the top. And again, if you want to, you can reduce it. Otherwise, as such, there is no need of reduction. So this part is all done. Now it says one of the students is chosen at random. Determine whether the events the student prefers hockey. So let me write this thing over here. The student prefers hockey. That is this thing. And then it says the student is at Amos College. So the student is at Amos College or Ben College. So it's a combination of both. A and B college are independent. So we are focusing on independence, justifying your answer. Now, the very first thing that I want to write over here is that when we talk about independent events, so for independence, probability of A and B, the common thing that should equal to probability of A multiplying with probability of B. Let me just check the voice and everything. The mic is open, all good, all clear. I'm just kind of worried about this. So now this is about hockey. This is about college A and B. So probability of hockey is how much? Probability of A and B college is how much? So hockey altogether, it's 220. And A and B college is 86 and 156. How much is that? 150 plus 80, 230 plus 12, 242. So this is 242. This is 220. So now hockey is 220 over 500. A and B is 242 over 500. I want you to double check also. Just double check these values. Hockey is 220 over 500. That is 220 over here. Let me underline this thing. So over here, I'm underlining this thing. That is 220. That is hockey. And this 2 adds up to 242. Now, is there anyone who is playing Amos, who's from Amos and playing hockey? Yes. Who's from Ben and playing hockey? Yes. So now this is the common thing, that is 32 plus 72. So over here, the common thing, that is probability of hockey and Amos Ben College. That is how much? That is 32, 72, 104. That is 104 over 500. That is the common thing. Now the thing is, this common thing, 104 over 500, is it really equal to 220 over 500 into 242 over 500? Now I would like you people to use your calculator and let me know whether these two are equal or not. I already have this answer. This answer, let me wait 1 second. Multiply out the right-hand side. Does it equal the left-hand side? And one way to do it is that multiply these two, divide by this. If it equals to 1, that means it's equal. If it does not equal to 1, it's not equal. As simple as this. Let me write down the value. This comes out to be 0.208. This multiplication is coming out to be 0.21296. It's close by, it's not equal. Therefore, the verdict is the two events, not they, the two events are not independent. So the two events are not independent, and that finishes this question number 2. Again, over here, 12:13. So this is 12:13 p.m. and question 2, it ends. Let's move to question number 3. Now, question number 3, it's about stem plot, as you can see, and then on the next page, it's about box plot and then reasoning. Okay, so now it says two machines, A and B, produce metal rods of a certain type. the length in meters of 19 rods produced by machine A. Let me highlight this. 19 rods are produced by machine A, and the same number of 19 rods are produced by machine B. It's not necessary they are the same. It could be different also. Is shown in the following back-to-back stem and leaf diagram. Now, I would focus on the key 7/22/4. So 22/4, I'm focusing on this. That is 0.224 meter for machine B. And this one over here, let me just change the color. So let me make it green color. This is machine A. There is 19 of them. So let me just choose this. Okay. So now for A, 7/22. Actually, it would be read like this. 7/22 means 0.227 for machine A. Find the median and interquartile range for machine A. So they always ask for the left-hand side because that is kind of tricky. So now let's focus on this. So first of all, what I'll do is that I'll write over here 19 divided by 2. That is 9.5, round it up. That is the 10th value. That is the median value. That is the first thing. That means T10 is over here. And then there are 9 small values on this side, 9 larger values on this side. Out of these 9, the mid value is the 5th value. That would be the lower quartile. And out of these 9, the 5th value will be the upper quartile. So now, first of all, let's locate the median. So the 10th value, you would start counting in this direction, So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10 over here, that is the median. So this is 8/23. So 8/23, according to this rule, this will be read as 238 with a decimal. That is the median. Now, once this is located, let's focus on the small values. So we need the 5th value for the lower quartile. 1, 2, 3, 4. This 5, that is the 5th value. So 1/23, it becomes 231 with a decimal. That is lower quartile. Similarly, go ahead of 8. So this is 1, 2, 3, 4, 5. That is the 5th value. 5/24. 5/24, that is 0.245. That is the upper quartile. And they are interested in the interquartile range. So therefore, interquartile range is upper quartile minus lower quartile. Upper quartile is 245 with a decimal, and lower quartile is 231 with a decimal. So the difference is 14. So that is coming out to be this much. Let me grab the calculator. So 14 with some decimals, and that is hold for a second. My calculator is gone somewhere. So that is 0.245 minus 0.231. That is 0.014. That is 0.014. That is the answer for this particular part. Median and quartile. So median is 238, lower quartile, upper quartile, interquartile range. Now it says it is given for machine B. The median is this thing. The lower quartile is this thing. Upper quartile is this thing. Draw box and whisker plot. Now, first of all, let me write B over here. Let me write lowest value, lower quartile, median, upper quartile, highest value. The same goes for A over here. That is the lowest value, the lower quartile, the median, the upper quartile, and the highest value. Now, first of all, for machine B, 232, 224. So this is 224. I'll ignore the decimals. 232, 243. And for over here, this is 231, 238, 245. 231, 238, 245. For A, the lowest value is 220 and 254. 220 and 254. For B, the lowest value is 211 and 256. 211 and 256. 211 and 256. Now you have to plot it, and you need a scale for this. So now look at the lowest value, that is 220, actually 211. No, 211 is the lowest. And then the highest is 256. So basically 210, 220, something like this. So let me just draw the line over here. And let me write over here, if I choose this thing as 210, this is 220, 230, 240, 250, 260. I think this is good. So always double check before you write it. So this is 210, 220, 230, 240, 250, 260. You can place the decimals later on. And for A, let me draw it in red color. So 220, 231, 220, 231, all good. And 238, 238 is over here. And then 245, 254. 245 and then 254. These are the 5 points for A. For B, I'm drawing in red color, 211, 224, 232. 211, let me go up all the way here. 211, 224. So that is 224, 232, 232. And then 243, 243. And 256, and then 256, that's right over here. Okay, so now what do? We draw, let me choose a red marker, a box of maybe 3 units up, 3 units down. That's a box over here. These are the whiskers. Again over here, 3 units up, 3 units down. The 2 boxes should be of equal width. It doesn't make a difference how much is the width. And naturally, you would be drawing it in pencil. Okay. So now this is for B. Doesn't make a difference which one is up, which one is down. This is for A. And basically, this is the lowest value, lower quartile, median, upper quartile, highest value for each one of them. So that's how these two are drawn. Now, what are they asking? They are asking us, what about, make 2 comparisons between the length of the rods produced by machine A and machine B. Now, first of all, machine A versus machine B. Let me write the median value. For machine A, it's 238 versus 232. 238 versus 232. The dots, don't forget them, like this. And what about the interquartile range? This is 0.014. And for B, how much is that? 224, 243, that's 0.019. 0.019. And we can also talk about skewness, but I think these two are better to talk about. Now, when we talk about median, we'll use the word typical value or average value. So we see that on average, the length of a rod A, rods produced by machine A. So let me write it. On average, rods produced by machine A are longer than those produced by machine B. Now, this takes time to write it down. So gather your thoughts and then write it down. Over here, the interquartile range of machine B is greater. So the rods produced by machine A have more variability or dispersion as compared to rods by machine. Uh, this is A and this is B. So let me correct this thing. So the lengths are more varied. The lengths are more varied. So I think this is also good statement. So now this thing is done and it's 12:24. So let me go up and write over here. So now 12:24, it took some time, PM, question number 3, it ends. So let me move on to the next question. Now, these questions, the histogram, the stem plot, the box plot, uh, cumulative frequency, they waste a lot of time. Now, the other questions, they are more mechanical in nature. So now let's continue with this thing. Let me grab my highlighter. Trees in a radian forest are classified as tall, medium, or short according to their height. The heights can be modeled by a normal distribution, mean 40, standard deviation 12. Trees with a height of less than 25 meters are classified as short. Now, these kind of questions we have done many, many times. It could be about the length of the journey. It could be about watermelons or melons, something like that. First part, find the probability randomly chosen tree is classified as short. First of all, state the distribution. X follows a normal distribution 40, 12 square. Variance goes over there. Probability X less than 25 is classified as short. So let's calculate the probability. Probability Z is lesser than 25 minus 40 divided by 12. I want all of you to grab your calculator so that you can work alongside me. And this is 15 over 12, which is a nice smooth number. Z is lesser than negative 1.25. Now, the rule is if there is a negative value, so what do? We flip the inequality and remove the negative sign, and we apply one of the 7 rules. These 7 rules are for X to Z to P, and that is how we take it out. So Z is greater than this value. Therefore, 1 minus probability Z is lesser than 1.25, which can also be written as 1 minus phi of 1.25. Now, 1.25, I have the normal distribution table ready so that we can also accommodate that time. So 1.25, so let me go this way. This is 1.2 and 5. I think this is 5. Yeah, this is 5. 8944. So we have this thing ready, and this is 0.8944. So 1 minus 0.8944. This comes out to be 0.1056. For over here, we will write this thing as 0.106, correct to 3 significant figures. The table will give us probability correct to 4 dp, final answer 3 sf. If I use it for any other part, which I will, so use unrounded value, unrounded 4 decimal place value. All good? Now it says of the trees that are classified as tall or medium, 1/3 are tall, 2/3 are medium. So now let me draw a number line. And let me write over here that this is lesser than 25. The probability is 0.1056. So this is 0.1056. Now somewhere here should be a value T. More than that should be classified as tall. So this is tall and this is short. And what is in the middle? The middle one is the middle one, medium. So this is medium. So now it says the medium is, the tall is 1/3. 1/3 are tall, 2/3 are medium. So first of all, what we do is that 1 minus 0.1056, that comes out to be 0.8944. It was also used upstairs. And 1/3 of 0.8944 is 0.2981. Therefore, this is 0.2981. And the medium one is 1 minus this, that is medium, but I don't need that. Show that the probability randomly chosen tree is classified as this thing, correct to 3 decimal places. This is 4 dp, Therefore, 0.298 is the answer. This is for tall. That is correct to 3 decimal places. All good, all clear? Let's move on. Find the height above which the trees are classified as tall. I have already done the groundwork. More than T is classified as tall. So I'll write probability X greater than T is 0.2981. That is the thing. And then what will I do? It's about back solving. First of all, realize this. Make sure this probability is at least 0.5. If it's not, then what do we do? Then subtract. If not, subtract probability from 1 and flip inequality. Basically, what we are trying to say is that X greater than T is 0.2981, approximately 30%. So therefore, this thing should be 70%. That is the concept, approximately. So therefore, probability X lesser than T is 1 minus this value, which is 0.7019. Now, 7019, let me again go to the table and find for 0.7019 the corresponding Z value. So 7019, that's right over here. That was an easy catch. So this is 7019 over here. And this is 0.5. This is 3. Therefore, this is 0.53. That is the Z value. So first of all, let me write over here that as 0.7019 probability is giving me a Z value of 0.53. Its lesser sign, Z value will be positive. Probability Z is lesser than T minus 40 over 12 is 0.7019. Probability Z is lesser than a positive value, which is 0.53 is 0.7019. Now do the working. That is, this thing over here should be equal to this. So therefore, T minus 40 over 12 is 0.53. Therefore, T is 12 into 0.53 plus 40. And this comes out to be 46.36. Again, round off to 3 SF, that is 46.4. Any units? If there is, I think meters or something. Yeah, meters. So that is 46.4 meters, correct to 3 significant figures. So now it's 12:32. So let me write over here, 12:32 p.m. Question number 4 ends. Let's move on. So now, question number 5. What is it about? It is about a fair three-sided spinner. Has sides numbered 1, 2, 3. It's a fair three-sided spinner. All the probabilities are equal. And then a fair five-sided spinner has sides labeling this. Both spinners are spun once. For each spinner, the number on the side on which it lands is noted. The random variable X is the larger of the two numbers if they are different, and the common value if they are same. That is common sense. Now it says, show that probability X is equals to 3 is this much. Draw up a probability distribution table. Now, first of all, let me draw up the table, and naturally this 3 thing will be coming out of that. So first of all, the fair three-sided spinner, that has the numbered 1, 2, and 3. I can write in either way. So let me write 1 here. Let me write 2 here. Let me write 3 here. And then I have the five-sided spinner. That is 1, 1, 2, 2, 3. So this is 1, this is 1, this is 2, this is 2, this is 3. So it's easier to have a look at this. Now, the common ones, the 1 and the 1, they will be written as 1. 2 and 2 will be written as 2. 2 and 2 will be written as 2. 3 and 3 will be written as 3. I think that is the one. Okay. So now if I compare it vertically, 1 and 2, I'll write 2. 1 and 3, I'll write 3. If I write over here, 1 and 1 is 1, there is also this 1. So I forgot this. Okay. And then 2 1s, 2 2s, 1 3, all good. So now over here, I have 1 and 2 is 2, 1 and 3 is 3. 2 and 1 is 2, 2 and 3 is 3. 2 and 1 is 2, 2 and 3 is 3. And the last one, 3 and 1 is 3, 3 and 2 is 3. So I think I have filled it up. And this is for double checking. 7 out of 15. Yes, there are 15 of them. And 3 is 7. So this is 1, 2, 3, 4, 5, 6, 7. All good, all clear. So basically, from the table, from the sample space diagram, so probability X is equals to 3. That is 7 possibilities out of 15. And the table says it all. And what other numbers are there? I have probability X is equals to 1. How many ones are there? 1, 1, and only 2. That's 2 over 15. How many 2s are there? So that is 1, 2, 3, 4, 5, 6. So that is 6 over 15. I think that's it. So that was pretty basic. 2 and 6 is 8. 8 plus 7 is 15. Just write it in the form of a table. So that is a table over here. And this is X. This is probability. So we have 1, we have 2, we have 3, we have 1 is 2 over 15. This is 6 over 15. This is 7 over 15. That is the probability distribution table. And I think that's too much space given. It's asking for expectation and variance. So let me write X. Let me write probability 1, 2, 3. This is 2 over 15. This is 6 over 15. This is 7 over 15, if I'm not mistaken. 267, 267, all good. Expectation of X, that is sigma Px, that is 1 into 2, 2 into 6, 3 into 7, and divide ones by 15 for making life easier for yourself and for the examiner. So 21 plus 2 is 23, 23 plus 12, that is 35. That is 35 over 15, leave it as it is. Expectation of X square, that is sigma Px square. So basically, we will take the value 1, square it, and multiply with 2. We will take the value 2, square it, multiply with 6. We will take the value 3, square it, multiply with 7, divided by 15. So 9 sevens are 63, 4 6 are 24. So 63 and 20, that is 83, 87, 87 plus 2, that is 89. So also double check my working. That is 89 over 50. Then we have variance of X, that is expectation of X square minus square of expectation of X. That is 89 over 15 minus 35 over 15 whole square. And use a calculator and then get the answer. Okay. So now that's how this thing is done. And this is 1237. So now 1237 is there and over here. So 12:37 p.m. Question number 5 is done and dusted. And then there should be question number 7 over here. No, first 6. And then question 7 ends. Okay. So now let me go back. Permutation combination, your favorite topic. So now it says, find the number of different ways in which 10 letters of the word summertime, S, U, M, M, E, R, T, I, M, E, summertime. So that's also coming your way once you're done with your exams. So 3 M's, 2 E's, and then we have S, U, R, T, I. Find the number of different ways in which 10 letters can be arranged so that there is an E at the beginning and E at the end. So E at the beginning. So let me write an E at the beginning. It's identical, only one option. E at the end, identical, only one option. And then we are left with 8 factorial divided by 3 factorial for the M's, 3 factorial for the M's, and that is the answer. Grab your calculator and divide, and one other things. How many E's are there? There is an E at the beginning and E at the end. So just divide, and can someone send me the answer so I can double check? And the answers are over here in the mark scheme. So hold for a second. Summertime, that is over here. 6B, 6A, 8 factorial, 3 factorial, 6720. Now, some students get this thing ready. 6720. So I want to write down the value. I just want to give the feel that we are using a calculator and we should write it down. 6720. That is the answer. Now it says, find the number of different ways in which the 10 letters of the word summertime can be arranged so that the E's are not together. That means the E's are separated. So therefore, let me write, there are how many M's? There are 3 M's and SURTI. So M, 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 and then we have SURTI. And let me draw some spaces in the middle. So 1 space, 2, 3, 4, 5, 6, 7, 8, 9. The number of spaces was always one more than the number of letters remaining. I need to fit in 2 E's. So I'll write 9P2. It's permutation definitely. Divided by 2 factorial because both are E's. And what about these 8? How can they arrange themselves? 8 factorial or 8P8 divided by 3 factorial for the M's. So the identical thing, that is for the M's over here, and the identical things for the E's over here. So now the working for this, and of course you can get the answer, and that would be the answer for this particular part. Now let's move on to this particular part, which I think it's about combination. Yes, it says 4 letters are selected. So now 4 letters are selected from the 10 letters of the word summertime. Find the number of different selection if the 4 letters include at least 1 M. At least 1 M. So it could be 1, 2, 3, and exactly 1 E. Now, first of all, let me write over here. What do we have? We have 2 E's. We have 3 M's. And we have SURTI. SURTI. So let me just, no, not this thing. Let me just push this to the side like this. Okay. It says exactly 1 M. Whatever the number of options are, let me just write few E's over there, exactly 1 E. And at least 1 M. So I can have 1 M, I can have 2 M, I can have 3 M. Can I have 4 M? No, first of all, there are no M's, and at the same time, we need a total of 4. So these are the different options that we have. Now we need 4 letters. So if I need 4 letters, what do? I have this one, that is 1 and 1 is 2, so 2 out of here. 1 and 2 is 3, so 1 out of here. 1 and 3 is 4, so 0 out of here. How many there are? 5. For the identical, we don't have to write any combination thing. We just select and discard the rest. So therefore, this is 5C2, which is 10. This is 5C1, which is 5. This is 5C0, which is 1. And it is simple addition. And this answer comes out to be 16. So that is how this particular question is done. Let's move on. Before that, 12:43, perfect timing. So this is 12:43. This is 12:32, 12:37, 12:43. And now we are on probably the last question. Excuse me. Now it says, on any given day, the probability that Moina messages her friend Pasha is 0.72. Find the probability for a random sample of 12 days. Moina messages Pasha on no more than 9 days. No more than 9 means at most 9 days. Just get used to this wording. no more than 9. That means 9 is inclusive, at most 9. Number of trials is given. Probability of success is given. This is binomial. X follows a binomial distribution, and this number of trial is 12. Probability of success is 0.72. I'll write probability X is lesser than or equal to 9, which is too much to calculate. That is 1 minus probability X is greater than or equal to 10. So therefore, this is 1 minus 12C10, two brackets, 12C11, two brackets, and then 12C12, two brackets that are over here. What goes inside the bracket? This is the probability of success, 0.72. This is 0.72. This is 0.72 raised to power of 10, raised to power of 11, raised to power of 12. And probability of failure is 0.28, 0.28, 0.28 raised to power of the difference between N and R. So this is 10, this is 2, this is 11, this is 1, this is 12, this is 0. And then you use a calculator. You calculate the probability. I want you people also to try it out, and let me grab the answer from here. So this is, they have done all this working over here. And let me just copy this if it's possible. Like this. And take a screenshot. Copy. And let's see if the pasting is done. Sometimes it causes a little bit of trouble. So now paste. Got. So now this thing goes over here. So this, what they have done is that they have shown the working for each individual probability. Even if you don't show the working, you can get the sum from the calculator. Write every step down, get the sum from the calculator, subtract, and this comes out to be, after the subtraction, 0.696, correct to 3 significant figures. Now, what is this? It says Moina messages Pasha on 1st January. So this is 1st, and then 2nd, and then 3rd, and then 4th, and then 5th. It's talking about till 5th. Moina messages Pasha on the 1st of January. The message is gone. Find the probability the next day on which she messages. The next day on which she messages is 5th. So now we are starting our journey from the 2nd, from here downwards. This thing is failure. This thing is failure. This thing is failure. This thing is success. Therefore, this is geometric probability distribution. You don't even have to state it. Just write down the probabilities. So there should be failure, which is 0.28. First day, second day, third day, so multiply by 3, multiply, raised to power of 3, multiply itself 3 times. And the last one, this is success. This is 0.72, and it's right over here. 0.28 cube into 0.72, 0.0158. That is 0.0158. That is the answer. Now, part C. Use an approximation. Find the probability. In any period of 100 days, Moina messages Pasha on fewer than 64 days. It's the same probability of success, but it's approximation. X follows a binomial distribution, 100, 0.72. N is 100. P is 0.72. Q is 0.28. First of all, calculate NP, which is 100 into 0.72, which is 72. Also calculate NQ, which is 100 into 0.28, which is 28. Also, you need to calculate NPQ. So NPQ, that is 100 into 0.72 into 0.28. I need a calculator for this. So this comes out to be 20.16. This is 20.16. First of all, justify. Justify that NP, NQ, NP, NQ. So write it down, even though the examiner has not asked for. Since NP is greater than 5 and NQ is greater than 5, therefore X follows a normal distribution, and we will write down the values. What values will be there? This is mean, that is 72. This is variance, that is 20.16. So now X follows a normal distribution, 72 and 20.16. Now it says fewer than 64 days. I need a number line. So for a number line, let me draw this. That's too thick. So over here, this is 64. This is 64.5. This is 63.5. Two options are there. One option is this one. The other option is this one. It says fewer than 64. 64 is not included. Therefore, the correct option is this one. So now probability X less than 64 after CC, continuity correction, becomes probability X is less than 63.5. Probability Z is less than 63.5 minus 72 over square root of 20.16. It's back to normal distribution. And this is probability Z lesser than some negative value, which will be converted to probability Z greater than a positive value. So let me again go back and let me grab this value because I have not done the calculation. And this is coming out to be 63.5, so I think negative 1.893 and 0.0292. So 1.893 and 0.0292. And this is 0.0292. This is 1 minus phi of 1.893 because this is greater. So we are going in this direction. This is 1.893. We will get the value from the table, 1.893, and subtract. Let me get this value. So now let me erase this thing. 1.893. 1.8 and 9 is like this, 9706, and then 3, 1, 2, 3. So 9708. So this is 1.9708, and that is giving me this answer, which is already in 3 significant figures. So that's how this paper is completed. It's 12:51. I think it's better than yesterday. We started at 12:05. We finish at 12:51. So how much is that? 46 minutes. That is a very good time to finish a paper that is designed for 1 hour and 15 minutes. So stay tuned for more content on mathematics with Shahab Yaqub. Take care, everyone.